In this tutorial, I'm going to talk to you guys about another important structure in Python called tuple. Tuples are similar to lists, so we can use them to store a list of items. But unlike lists, we cannot modify them. We cannot add new items. We cannot remove existing items. We say tuples are immutable. We cannot mutate or change them. Let me show you. So I'm going to start by defining a list of numbers, 1, 2, 3. So we use square brackets to define lists and parentheses to define tuples. So if we change this to parentheses, 1, 2, 3, now we have a tuple. So if we type numbers dot, look here, we don't have the append or insert methods. So we cannot add new items to this tuple. We also don't have remove, clear, and pop. We cannot remove any of these items here. We only have two methods, count and index. We use count to count the number of occurrences of an item and index to find the index of the first occurrence of an item. So we can only get information about a tuple. We cannot change it. And by the way, these other methods that you see here, they start with 2 underscores. We refer to these as magic methods. They're more of an advanced topic, so they go beyond the scope of this tutorial. If you're interested to learn about them, you can get my Python course. I've covered them in detail. So similar to lists, we can access individual items using square brackets. So we can get the first item like this and then print it on the terminal. There you go. The first item is 1. But if we try to change the first item, we'll get an error. So numbers of 0, we set it to 10 and run our program. There you go. We get this type error because the tuple object does not support item assignment. So we cannot mutate or change tuples. They are immutable. Now, practically speaking, most of the time you'll be using lists, but tuples are also useful. If you want to create a list of items and you want to make sure that nowhere in your program you accidentally modify that list, then it's better to use a tuple. In this tutorial, I'm going to show you a powerful feature we have in Python called unpacking. So let's define a tuple called coordinates. And here we pass 3 values, 1, 2, 3. So imagine these are the coordinates for x, y, and z. Now let's say we want to get these values and use them in a few expressions, in a few complex expressions in our program. Maybe we want to include them as part of a large complex formula. So to get them, we'll have to write code like this. Coordinates of 0, then let's say we want to multiply this by coordinates of 1, and then multiply it by coordinates of 2. Our code is getting a little bit too long. This is just a very simple example. But let's say we want to use these values in quite a few places in our program. So a better approach is to get these values and store them in separate variables. Like we can get coordinates of 0 and store it in x. Then we get coordinates of 1 and store it in y. And similarly, we get coordinates of 2 and then store it in z. Now, instead of repeating coordinates of 2 or coordinates of 0 multiple times, we can simply work with these variables, x times y times z. That is better, right? So nothing new so far. But in Python, we have a powerful feature called unpacking. And with that, we can achieve the same result with far less code. So we can define our variables x, y, and z and set them to our tuple. What we have on line 6 is exactly identical to what we have on lines 2 to 4. So this is a shorthand to achieve the same result. So let me delete this and explain how this code works. When Python interpreter sees this statement, it will get the first item in this tuple and assign it to this variable. Then it will get the second item in this tuple and assign it to the second variable. And similarly, it will get the third item in this tuple and assign it to the third variable we have here. So we are unpacking this tuple into 3 variables. Now, if we print x, you can see x is 1. Similarly, y is 2. There you go. So this is unpacking. And by the way, this is not limited to tuples. We can use this feature with lists as well. So if I change parentheses to square brackets, now coordinates is a list. So we can unpack this list into 3 variables. Now, run our program. You can see y is 2. In this tutorial, I'm going to talk to you guys about dictionaries in Python. We use dictionaries in situations where we want to store information that come as key value pairs. Here's an example. Think of a customer. A customer has a bunch of attributes like name, email, phone number, address, and so on. Now, each of these attributes has a value. For example, the name can be John Smith, the email can be john@gmail.com, the phone can be whatever. So what we have here is a bunch of key value pairs. So in this example, our keys are name, email, and phone, and each key is associated with a value. So this is where we use a dictionary. With a dictionary, we can store a bunch of key value pairs. So let me show you how to define a dictionary in Python. Back to our program, I'm going to define a variable, customer, and here we set it to curly braces. With these curly braces, we can define a dictionary. In this example, we have an empty dictionary that doesn't have any key value pairs. Now we can add one or more key value pairs in between the braces. So let's add a key value pair here. I'm going to set the key to name and the value to John Smith. Then we add a comma to add another key value pair. So let's set age to 30. Let's add another key value pair is underline verified. And we set this to a Boolean. Now what matters here is that these keys should be unique. So if I add another key value pair here, let's set age to 40. Now look, PyCharm has highlighted the age key because we have duplicated that, and that's not allowed. So each key should be unique in a dictionary, just like the dictionaries we have in the real world. In a real dictionary, we have a bunch of words and their definition. Each word is listed only once in a dictionary. We don't have the word book twice. So let's delete this second duplicate key value pair. So the keys should be unique. And in this example, I'm using strings, but they can also be numbers. We're going to look at that later. But the value can be anything. It can be a string, a number, a Boolean, a list, literally anything. Now we can access each item in this dictionary using square brackets. So we type customer, square brackets, and then specify a key, like name. And this will return the value associated with the name key. Let's print it on the terminal, have a look. There you go. So the name is John Smith. Now, what if we pass a key that doesn't exist? Let's say birth date. Run the program. We get a key error because we don't have a key called birth date. Also, if you spell name with, let's say, a capital N, we get the same error because we don't have a key with the exact same sequence of characters in this dictionary. Now, to get around this, we can use the get method. Let me show you. So instead of using the square brackets, we call the get method and specify our key. Now, if we use a key that doesn't exist here, it doesn't yell at us. For example, if we pass birth date, it simply returns the none value. Earlier, I told you that none is an object that represents the absence of a value. So instead of getting a key error, we get none. Now we can also optionally supply a default value. For example, if this dictionary doesn't have this key, we can supply a default value. Let's say January 1st, 1980. Let's run the program. Now, instead of getting none, we get this default value. So this is how we can access the value associated with a key in a dictionary. We can also update these values. For example, before a print statement, we can write code like this. Customer of name. Let's update the name to Jack Smith. Now, this little warning here is telling us that we could simply put Jack Smith here instead of defining it once and then update it. Don't worry about that. It doesn't really matter. Now with this line, if we print the name of this customer, we should see Jack Smith. Let me show you. So I'm going to use the square bracket notation again. Let's print the name of the customer. You can see that is updated here. We can also add a new key here. Let's set the birth date to some value like January 1st, 1980. And then we can print it here. So as you see, we can easily add new key value pairs to a dictionary. So this is the basics of using dictionaries in Python. They're extremely important and they have a lot of applications in the real world. Okay, here's an exercise for you. So here we have this program that asks our phone number. Let's type 1234. we type it in digits, and then this will translate it to words. Take a look. Enter. It prints 1, 2, 3, 4. That's a pretty cool program. So go ahead and spend a few minutes on this exercise. That's pretty easy. I will see you next. All right, so first we need to get the user's phone number. We call the input function with the label phone. We get the result and store it in this variable. Now let's say the user enters 1, 2, 3, 4. So we need to loop through this string, get each character, and translate it to a word. So what we need to implement this scenario is a dictionary, because a dictionary is a structure that allows us to map a key to a value. So we can have a dictionary with keys like 1, 2, 3, 4, and we map each of these keys to a word. So we can map the digit 1 to the word 1. We can map 2 to TWO. You got the point. So let's define a dictionary. We can call it digits underline mapping. Now in this dictionary, I'm going to add a few key value pairs. 1, we map it to 1, 2 to 2, 3 to 3, and finally 4 to 4. Now technically we should add all the digits from 0 to 9, but I don't want to waste your time typing repetitive things here. You got the point. So let's move on. Now we need to loop through the phone string. So for character in phone, we get each character and then use it to access a key value pair in our dictionary. So digits underline mapping, we can use square brackets or call the get method. I would prefer to use the get method. So in case the user enters some character that is not part of our dictionary, our program is not going to yell at them. So we call the get method and pass this character as the key. And if we don't have this key, we can supply a default value like an exclamation mark. So with this, we'll get a word. Now we need to add this word to an output string. So we can define an output string. Initially, we set it to an empty string. In each iteration, we get this and add it to our output string. So we type output plus equals this. And we should also add a space at the end. So the words are not close to each other. Okay, that's all we have to do. Now, finally, let's print this output, run our program. So I'm going to type 1, 3, 4, 5. Let's see what we get. We get 1, 3, 4 with an exclamation mark. In this tutorial, I'm going to show you something really cool that you can do with dictionaries. So here we have this program. We can type a message like good morning, followed by a smiley face. When we press enter, we get this beautiful smiley face. Or we can type I am sad with a sad smiley face, and it gets translated to this beautiful emoji. So this is another application of using dictionaries. We have a dictionary that maps these characters into smiley faces. So let's go ahead and build this program together. We start by calling the input function. Here we pass a greater than symbol as an indicator for the user to type a message. We get that message, store it here. As you know, that is a string. Now we need to split the string by a space. So if the user types good morning with a smiley face, we want to break this down into 3 words: good, morning, and smiley face. To do that, we can call the split method. So we call message.split and pass a string with 1 space as the separator. What this method does is basically it goes through the string, and anywhere it finds this character, in this case a space, it uses that as a boundary to separate this string into multiple words. And then it will return a list. Let me show you. So let's store that here, words, and then print it on the terminal. Let's go ahead and run our program. So if we type good morning sunshine, enter, we get a list with 3 items. Each item is a string. Okay, now back to our program. We need to define a dictionary for mapping special characters like these 2 into a smiley face. So we can call that emojis, set it to curly braces. Here we add a key value pair, a smiley face, and we map that to a string. In the string, we want to add an emoji. If you're on a Mac keyboard, you can press Control, Command, and Space, and this should bring up this emoji box. If you're on Windows, honestly, I really don't know how you can do this, but there must be applications that do this for you. So let's go ahead and pick this happy smiley face. Good. Now let's add another key value pair for a sad face. We map this to this face here. Good. So we have a list of words. Now we need to loop through this list, get each word, and potentially map it to an emoji. So we can write a for loop for word in words. Now we want to go to our dictionary and see if you have an item with this word as the key. If you have an item with that key, then we'll get its value. Otherwise, we want to use the same word. So if the user types good morning, we don't want to translate those words. We just want to return those. So that is the case where we use the get method to supply a default value. So we want to get an item with the key word. And if we don't have an item with that key, we simply use that word as the default value. Now, similar to the exercise that we did in the last tutorial, we need an output variable. So let's define that here, output, set it to an empty string. Now back to line 9, we get the return value of the get method and add it to our output variable. So output plus equals whatever we get from the get method. And finally, we need to append a space at the end. That's it, we're done. So let's print the output and run our program. I'm going to type good morning, sunshine with a smiley face. We get that, beautiful. Let's try a sad face as well. I am sad, too bad. Beautiful. So as you can see, dictionaries have a lot of use cases in real applications. Here's a solution from the last tutorial where we created an emoji converter. Now, so far we've been writing all our code right here in app.py, but as our programs grow, we need a better way to organize our code. We need to break up our code into smaller, more manageable, and more maintainable chunks, which we call functions. So a function is a container for a few lines of code that perform a specific task. For example, you have learned about a few of the built-in functions in Python like print and input. Each of these functions have a purpose. They know how to perform a specific task. So when building large, complex programs, we should break up our code into smaller, reusable chunks, which we call functions, to better organize our code. And that's what I'm going to show you in this tutorial. So let's write a simple program for printing a greeting message. So we're going to do a print, hi there, and let's add another message, welcome aboard. So here we have a simple program with only 2 lines of code. Now let's say these 2 lines, potentially we're going to need them in other programs. So we can put them in a function that we can reuse. Let me show you how to do that. So we start typing out def, that is a reserved keyword in Python, and it's short for define. When Python interpreter sees this, it knows that we're defining a function. Next, we need to give our function a name. Let's say greet underline user. So all the best practices you learn about naming your variables also apply here, which means you should name your functions with lowercase characters. If there are multiple words, you need to separate them using an underscore. And you should always use meaningful and descriptive names for your functions. So here we're defining a function called greet user. After that, we need to add parentheses followed by a colon. Now, you know that whenever we add a colon at the end of a line, we're telling Python that we're defining a block of code. So when we press enter, the next line is indented. Now, any code that we write here will belong to this function. So I'm going to move these 2 lines, these 2 print statements inside of our function. We can simply press tab to indent them. Beautiful. Also, let's remove this extra line break. That is better. So these 2 lines now are part of our greet user function. So whenever we call this function, these 2 lines will be executed. Okay. Now let's remove indentation. So here we are outside of our function. Let's do a print statement and print start. After that, let's call our function. So greet user. And finally, let's do another print statement and print finish. Now we have this little warning here, this underline. If you hover your mouse over this line, This tooltip is telling you that we should add 2 blank lines after a function definition. This is coming from PEP 8, which is a document that defines the best practices for formatting our code. We'll look at that in the future. So for now, to make PyCharm happy, let's add an extra line break after this function. So whenever we define a function, we need to add 2 line breaks after. Okay? So now let's run our program and see what happens. All right, so we get 4 messages on the terminal. First, we get the start message. Then we get the messages coming from our greet function. So hi there and welcome aboard. And finally, we see the finish message. So let me explain the flow of our program. When Python runs this code, it doesn't actually print these 2 messages on the terminal because these lines of code are inside of this function. So they will only get executed if we call this function. If we don't call this function, these lines will not get executed. Okay? So the execution of our program actually starts here. The first message that we see on the terminal is the start message. After that, Python sees that we're calling the greet function. So it will jump over here and then execute these 2 lines. Then it will jump outside of this function and continue the normal execution of our program. So it will print the finish message on the terminal. So this is how functions work. Also note that the order of this code matters. So here we're calling the greet function after we have defined it. If you try to call it before you define it, you will see an error. For example, if we call the greet user function right here, see, we immediately get this red underline, which says unresolved reference greet user, which basically means Python doesn't know what is this greet user. It's not defined anywhere. So we always define our functions first and then call them. Here's the function we created in the last tutorial. Now I got a question for you. What is the difference between calling this function and the print function of Python? The difference is that the print function takes some information, in this case, the message that we want to print, but our greet function doesn't take any information. Wouldn't that be nicer if you could pass the name of the user here, and then instead of saying, hi there, we could print the name of the user. So in this tutorial, I'm going to show you how to pass information to your functions. And that is pretty easy. So back to the definition of our greet user function. Inside of this parenthesis, we can add parameters. These parameters are placeholders for receiving information. For example, we can add a name parameter, and with this, we can pass the name of the user when calling this function. So let's pass John here. Now, when we call this function and pass this value, this name parameter will be set to John. So it will act like a local variable that we define inside of this function. Just imagine we didn't have this parameter, and instead we had a variable like name that was set to John. Now here, we could simply print the name of this user. So we could use a formatted string and print the value of the name variable, right? Now, we don't really have this local variable defined in this function. We have a parameter. It's exactly the same thing. So with these parameters, we can receive information in our functions. Now let's go ahead and run this program. So take a look. We get, hi John, welcome aboard. We can take this to the next level. Now we can call this function one more time. So greet user, and this time supply a different name. Let's say Mary. So we are reusing our greet function and passing it a different value. Imagine if we didn't have this function, we would have to repeat this line twice. Once for hi John and another time for hi Mary. So this is the benefit of defining functions. We can take a few lines of code that have a specific purpose and put them inside of a function. So now let's run our program one more time. There you go. So we get hi John, welcome aboard. Then we get hi Mary, welcome aboard. Now note that when a function has a parameter, we are obligated to pass a value for that parameter. So if we remove John from here and run our program, we get this type error, greet user missing one required positional argument. Argument in programming is the value that we supply to a function. So back to this example, Mary in this case is an argument that we pass to the name parameter. A lot of programmers don't know the difference between parameters and arguments and think they are the same, but they are not. Parameters are the holes or placeholders that we define in our function for receiving information. Arguments are the actual pieces of information that we supply to these functions, okay? So let's bring back this John string, okay? Now we can also define multiple parameters. For example, let's rename this parameter to first name. As I told you before, you can right click here, go to refactor, and then rename, or preferably you can use a shortcut. So the shortcut for this on Mac is Shift and F6. And this brings up the rename dialog box. Here we can change this to first underline name. Now we can add a second parameter, so comma, followed by last underline name. So back to our formatted string, let's also print the last name. Beautiful. So here when calling these functions, then we can supply another argument. So John Smith, and let's delete this line. We don't really need it anymore. Run our program. Take a look. Hi, John Smith. So in the last tutorial, you learned that whenever we define parameters for our functions, we should always supply values. Otherwise, we'll get an error. Let's look at that error one more time. So I'm going to delete the second argument and only pass John. Run our program. We get this message. Greet user, missing, 1, required, positional argument. So these arguments that we have here, like John and Smith, we refer to these as positional arguments, which means their position or order matters. In other words, the first argument we add here is the value for the first parameter, and the second argument is the value for the second parameter. So if we change their position or order, we'll get different result. Let's take a look. Let's pass Smith first and then John. Okay. Delete. That's good. Let's go with this. So instead of getting hi John Smith, we get hi Smith John. So that is the reason we refer to these arguments as positional arguments. Their position or order matters. But in Python, we also have keyword arguments, and with those, the position doesn't matter. Let me show you how they work. So let's say here we want to pass John as the value for the first name parameter. We can simply specify that here. So first name equals John. Now what we have here is a keyword argument. So this combination of having the parameter name followed by its value is what we call a keyword argument. And with these keyword arguments, the position doesn't really matter. So here we're supplying John as an argument for the first parameter. Now, similarly, we can use a keyword argument for Smith. Let me show you. So last name equals Smith. So now we have two keyword arguments. So with these keyword arguments, we don't have to worry about the order of the parameters. That doesn't mean we should always use keyword arguments. Not really. Most of the time, we use positional arguments. But in certain situations, these keyword arguments help us improve the readability of our code. So on line 7, it's quite clear that we're supplying Smith as the last name and John as the first name. Now in this particular example, even if we didn't have the keyword arguments, just passing two positional arguments like John and Smith would be sufficient because it's easy to guess what is the purpose of these arguments. But sometimes you're dealing with functions and you're passing numerical values to them. In those situations, it may not be quite clear what these values represent. Let me show you an example. Let's say we have a function for calculating the total cost of an order. So we can call that calculate underlying cost. So when calling this function, we need to supply three pieces of information. One is the total cost of all the order items, let's say $50. The other is the shipping cost, let's say $5. And the last piece is a discount, let's say 0.1. Someone reading this code may not be sure what these three values represent. In this case, we can improve the readability of this code by using keyword arguments. So we can prefix each value with the name of the parameter they target. For example, we can set total to 50 and then shipping to 5 and discount to 0.1. Now, if we give this code to someone else, they can immediately tell what these values represent. So that is the power of keyword arguments. So here's what I want you to take away. For the most part, use positional arguments But if you're dealing with functions that take numerical values, see if you can improve the readability of your code by using keyword arguments. You simply prefix the arguments that you pass with the name of their parameters, and this will increase the readability of your code. Now, there is one more thing you need to know about keyword arguments. These keyword arguments should always come after positional arguments. Let me show you what I mean. So, back to our simple greet user function. Let's use a keyword argument for the first name. So, let's set first name to John and see what happens. Look, we immediately get this error. Take a look. Positional argument after keyword argument. So when calling this function, we're supplying one keyword argument and one positional argument. And Python doesn't like this. So if you're mixing positional and keyword arguments, you should always use the positional arguments first and then the keyword arguments. In other words, let's remove this keyword argument here. So John is now a positional argument, is targeting the first parameter, right? Now, after this positional argument, we can supply any number of keyword arguments. So if we set last name to Smith, look, Python doesn't have any problem with this because we're adding a keyword argument after a positional argument. So let's quickly recap. For the most part, use positional arguments. If you're dealing with functions that take multiple numerical values and it's not quite clear what those values represent, use keyword arguments to improve the readability of your code. And finally, if you're passing both positional and keyword arguments, use the keyword arguments after the positional arguments. So far, you have learned how to create functions and send them information using their parameters. In this tutorial, I'm going to show you how to create functions that return values. This is particularly useful if you're doing some kind of calculation in your function and you want to return the result to whoever is using your function. Let me show you. So let's start by defining a function called square. This function simply calculates the square of a number. So we need to add one parameter here, that is our number. Now here we want to calculate number times number. That is the square of a number. Now, to return this number outside of this function, we simply use the return statement. So return. Now, our square function is very simple. It only has one line of code. But in a real program, you might have a function that has 10 lines of code to calculate something. So this return statement is very valuable. With that, we can return values to the callers of our function. So with this, when we call the square function, let's say we give it 3. Now this function returns a value, just like the input function of Python. This input function waits for the user to type something and press enter, and then it will return the user's input as a string. So we can get it and store it in a variable like this, right? We have the same story with our square function. So our square function returns a value. We can simply get it and store it in a variable. Let's call that result. Now we can print result on the terminal. There you go. So result is 9. We could also pass this function call directly inside of the print function without defining a separate variable. Sometimes this is useful for writing shorter code. So in this case, we don't really need this result variable. We simply want to print the square of 3. So we could simply pass this function call right here as an argument for the print function. So let's delete this variable. Now our code is shorter. So with this, we're calling the square function. This returns a value, and we'll pass that value as an argument to the print function. Okay? When we run this program, we get the exact same result. There you go. Now, what happens if we don't use a return statement in our function? So in the last example, we simply used a print statement. Let's temporarily remove this return statement and print the result on the terminal like this. So let's run our program one more time and see what we get. We get two things on the terminal, the number 9 and none. What is happening here? Well, when Python interpreter executes this code, first it will call the square function. So the control moves to the square function. Here we calculate the square of this given number and then print it on the terminal. That is the reason we see 9 right here. Now, by default, all functions return the value none. So if we don't have a return statement here, by default, Python returns none. None is an object that represents the absence of a value. It's like nothing, or null in C, C++, Java, and JavaScript. So in this example, we didn't have a return statement, and by default, Python returned none from this function. So after this square function is executed, the value none is returned and passed as an argument to the print function. That is the reason we see none on the second line. So here are the two things you need to take away from this tutorial. By default, all functions in Python return none. You can change that. So if you have a function that calculates something, you can return the result using the return statement.